So today we're going to take a look at the basics of RAM structural system. And all I've done here so far is I've opened up the program, and really this tutorial is meant for people that have never used the program before, kind of to get an intro of how the system is set up. And all we're going to be looking at is a gravity system. So if we're not really going to get into lateral design here, but basically all I've done so far is open this up, and what we're going to take a look at is we're going to try and model a building that maybe looks like this, where we have a floor framing plan with a couple of stair openings and nothing too crazy here, maybe a roof plan with an HVAC unit, something like that. And we're going to go ahead and model this. So when we get started here, the first thing to notice is just how RAM is set up. And you'll notice that there's different menus up here, and these criteria you can go ahead and set. You can go change your models and all those things, but the first thing you want to really do is just to create a new project. So you create a new project, maybe we'll call it something. I'm just going to stick this on my desktop for now, and when I put it on my desktop, I'm just going to call it a simple project. And you can name it whatever you want to. If you're working in the cloud, you can assign this project, register it. We're not going to do that here, and you can just hit cancel and keep moving on. So when this opens up, you see the modules that are available that we can work with. And what you see on the left-hand side is these modules kind of show up here as well. And then along the top, you have different menus that you have to be able to work with. And under File, you can use a couple different features here. You can put job notes in or job name if you want to. Under criteria as well, you can take a look at member load, self weight. Honestly, member loads is one of those really good ones to take a look at, because where we are and where we're looking at with this model, snow load is going to be important. So we're going to take a look at snow load and not roof live load. Snow load in our case is going to be bigger than the roof live load, so we're going to have to do snow load. You can also do reducible or unreducible. I like to start with unreducible loads just because it makes it easier for hand checks and that sort of thing. You can always go back and change that later. If you want to change your live load reduction method, you can do that as well. But here again, if your snow is bigger than your roof live load, you really need to change it here, because RAM can do either snow load or roof live load, but it can't do both. Okay, so if we come back here, we can take a look at self weight as well. And again, when I'm first starting to learn how to use a program, I like to turn the self calculation of like slab and deck weights off, because what I like to be able to do is to be able to come up with those numbers to basically check that my model is doing it correctly. And if I can know what my beam weight is, just if I put in my beam self weight, I can always go turn this on later, right? But I'm going to leave it off for now. And what I'm going to do is I'm going to include my beam weight maybe with my dead load. I'm going to include the slab deck weight with the dead load, okay? And then story masses, you can do the same thing here. You can turn them off, but these story masses really are going to get into your gravity seismic analysis, which we're not going to look at in this video. So I'm going to click OK for that. But basically what that means is now I have to add my self weight to the dead load. And then if I come in here, I can take a look at different RAM tables depending on where I'm designing. Whether I'm India, Canada, or UK, or wherever, I can change my master steel table. In addition, my design steel tables, same thing with decks and columns and beams and joists. I can change these depending on what part of the world I'm working on. They're working in. Concrete tables. This video is not really going to deal with concrete. Eurocode, Canada. Some of these other standards here we're not going to worry about. Units, I'm going to stay in English units for this video. And then once we have our criteria set, we want it to come to our model. You can click model up here, you can click model on the left. It'll bring you to the same place. And this is your model. It's blank, it's new, there's nothing there to start. So once we go there, what we want to do next is we want to go, and again with this, we kind of want to work in a left to right format here, right? So under File, there's really nothing. We can see our model status if we want, but here you'll notice that we can design with different materials. So whether it's a steel beam or a steel joist or a C-beam, we can change our material if we need to. We can change our properties. I'm actually going to come back to these once I set my model up a little bit more. But the first thing that you really want to do, or that I like to do when I come to this, is just to work through this layout drop down. So in the layout, the first thing that we're going to do is we're going to select a type of layout. And this is where I need to define it. So I'm going to create, let's say, a floor layout. And I have to click Add to add that. So then I'm going to then I'm going to also click select to select it. And you'll notice now that we have a floor layout, right? And it looks blank because we haven't defined anything yet. And one of the things that you have to do next is you have to go, and the next thing you have to do is actually define your grid. So I'm going to come in here and define my grid. I'm going to create this, I'm going to edit it. I'm going to call this just my basic grid. And you can have multiple grids in one floor, right? So if you have an orthogonal section, you can do an orthogonal section, and then you have a radial section, you can add multiple grids, and they'll both show up so that you can add columns on different places, okay? But here, I'm going to add this, and then before I do anything else, I have to go and edit this grid. So I'm going to come in here and edit the grid, and I'm going to call my grid label. This is where, if we look at our grid, what we see is up here we have 1, 2, 3, 4, A, B, C. This is 26 feet, 22 feet, and then we can come back and take a look. So when we're in the x-axis here, the x grid, I'm going to go for 1. I'm going to start at 1. I'm going to call my grid coordinate 0. I'm going to do my grid spacing of 26 feet to match that x grid spacing. I'm going to say I want 3 more grids, and then I'm going to have my automatic ascending because I want to go 1, 2, 3, 4. I'm actually going to display my label at the end of the grid, this will be the top, and I'm going to click add. Okay, so this gives me 4 grids, 1 through 4, 26 feet apart. And then I need to come to my Y grid. And this is where it gets a little bit interesting because now the way that this was set up, if you remember, we go from kind of D, C, B, A. So when I come back to RAM, I'm going to start at D, I'm going to start at 0, and then my grid spacing is going to be 22 feet. I'm going to have 3 additional grids, but here I'm going to pick descending because I want to go from D up to A. So if I add these, I go from A, B, C, D, and let's see how that looks. So I click OK, and it looks like nothing. So you think maybe I did something wrong. Well, no, actually you didn't do anything wrong yet. So what we have to do is now under the grid, we actually have to select a grid for this floor layout, right? So I'm going to come in here, I'm going to pick my grid, I'm going to click OK. And what you can see here is we start at 1, 2, 3, 4. We go A, B, C, D, just like we wanted to from the file from the plan that we got, okay? So then we have our grid. Our grid is all set. And what we want to do next is we just kind of want to work through this layout drop down. So we did our type, we did our grids. Now we're on to columns, okay? And with columns, what I'm going to do is I'm going to add those on the grid. So the reason I made this grid is because I want to put columns at each of these intersections. So what I'm going to do is I'm going to start here. I'm going to have a standard column. You can't have hanging columns where they're not attached below, stories below. You can have lateral columns that are part of your lateral force resistant system. For this video, all we're doing is gravity. So we're going to say this is gravity, and our columns are actually going to go straight up and down. And then I'm going to apply this in a fence. And with a fence is nice because you can just pick an area and assign columns to the grid. Okay, so you'll notice that I left these corners off because those aren't in the framing plan. So our columns are set. I can right click and go to cancel this as well. So those columns are in. Sometimes as well you'll have different standards with what you use for properties, for eccentricities, for fixities, those types of things. Eccentricities, what I'm going to do here is I'm going to say my distance is going to be, maybe 3 inches to the column plus half the column dimension. And then similarly down here, maybe I'll use the absolute distance for this from the center line for the weak axis. And maybe instead of 3 inches, I'm going to use 3 1/4, and I'm just going to say, that 1/4 inch will take me half the web of that column in the weak axis. So that's going to give me, kind of the distance to my simple shear connection. So now I can click fence and apply this to all of these columns. And it kind of looks like nothing changed, but you can see that it does. So if I right click and hit cancel, if you're ever interested to know what the properties are of your column, right, you can click on columns, show, and then when you click on a column, for example, it'll show all these properties. So it shows the eccentricity that we just applied. It also shows, the column coordinates, orientation, and the other properties that are set for it. Okay, so these are columns, If you wanted to add something, a column off the grid, you could do that as well. Or you can move a column, or you can offset a column, or there's other options in here. So after we get our columns set, we're going to move on to beams. And typically what we're doing for beams is we're adding these on the grid. They're going to go between columns. And I'm going to start with adding them on the grid. So these are going to be gravity columns. I'm going to start with non-composite design. You can always come back here and switch this to composite design when you're done. Right, but especially when you're first getting started, it's nice to just be able to use, WL squared over 8 and look at FYZX, for your plastic moment and those sorts of things, just to check, to make sure that you're understanding how the inputs go in correctly. So I'm going to click non-composite gravity beams, and I'm going to just select basically everywhere I want to put those beams. And you'll see again, I'm just putting those in the places where we had beams on the framing plan. So once I get that though, what you'll notice is I had some places, especially for like a floor, where maybe we had some of these stair openings, and we have to take a look at what to do with those stair openings. So what I'm going to do here is I'm going to come back and I'm actually going to add some beams off the grid. Okay, so what I'm going to do is I'm going to take this, and now I'm going to right click and cancel. And here I can come back and I can assign a beam off the grid. And specifically what I'm going to do is that stairwell, had a beam that was 10 feet apart. So I'm going to say I'm going to go parallel to the beam, 10 feet apart, and that's going to get me, another beam kind of right in here. So I click on the beam that I want, and then you'll notice these two white lines show up, and then I click to the side where I want to put an offset beam. And then also I can right click to get back to my menu. And now I can say, well, I want to offset this 18 feet because that was the other dimension. And I'm going to come here and offset it 18. And I'm going to come here and offset this one as well, 18. So those are all the beams. I've added a couple off the grid as well. And those are, the steel framing. If you're framing this whole thing out of beams, you can just keep going and adding those. But what we're going to do in this one is we are going to actually add some steel joists. So I'm going to come up here first, and now I'm going to go to steel joists because I want to add some steel joists. And now when I come to layout, you'll notice that instead of beams, I have joists, and I have a very similar menu here. But now what I can do is I can add these joists, and I'm going to add these using generation. And I'm going to say, well, okay, I'm going to use, let's say 5 equal spaces. Okay. So I'm going to take that and I'm going to click add. And now what I can do is I can just click, and then my third click is going to say which side I want these to go to. So I'm just going to click, third side, click, and then third click takes me to which side I'm generating these on. So all I'm doing is just putting these wherever I want my joists. They're going to span in the long direction. And you'll notice that I kind of stopped over here because I can't really add all these joists in, because if I do that, well, it sort of gets a little funny here. And I could do that, but let's say we want to change this a little bit. Maybe we don't want this joist is a little too close. So what I can do in here is I can hit cancel. I can actually come back, go to my joist and delete, right? So I can delete a single one, I can pick this one, I can pick this one, and maybe instead I just want to put one back in there. Okay, so I can come back in here and I can go to my joist and I can do maybe add off grid here. And now I'm going to say maybe I can offset 5 feet parallel to the beam. So I know this is a 10-foot space, so I can click add and I can click a joist in here, right? So I mean, that makes a little bit of sense, right? That where we're going to offset this and make it maybe split the difference. Okay, so now our joists are set. So that's pretty cool. And what we want to do next is we want to go and enter and basically come in and let's take a look. So the next thing that we're going to do is we're going to define a slab. And you might be thinking like, this is a steel building, why are we defining a slab? Well, in what we're doing here, we're going to put a composite deck on this whole floor. So it's going to be a composite concrete deck. I can define a slab edge here, and I'm going to say, I'm going to maybe make this overhang, let's say 8 inches, and I'm going to apply this to the whole perimeter. Okay, and what that does is you can see the green line shows up now, and this is applying a slab to that whole perimeter of the floor. I'm going to right click and hit cancel. So that's all applied. Then even within the slab, what I can do is I can come back and I can add slat openings. So I'm just going to click in bay to say, okay, these are going to be 2 stair openings. I'm putting openings there, and when I right click and hit cancel, you'll see those openings show up now. Okay, so that's my slab. If you had slab penetrations, you could put those in, but you'll notice when I come to deck assign, there's no deck. Okay, and that's where we have to kind of go backwards just a little bit. So I mentioned earlier that we weren't going to set up our properties quite yet, but now's the time to go back and set up our properties. So I'm going to come here and I'm going to go to decking, and within decking I might have a composite floor system, and I mean, you could use a USD B-lock floor, you could use Volcraft. Let's just use Volcraft. So I'm going to use, composite. I'm going to have eventually I'm going to maybe leave this in, the studs in, and I'm going to say it's not going to be shored. I'm going to call this 1.5 VL, 5-inch deck. So let's say that we have 3.5 inches of concrete above the flute. Let's say we have 4-inch studs, 150 pound per cubic foot concrete, or maybe we could go to 145. All right, we could use F prime C of 4 or 4.5. We could use our stud FU of 65 is fine. A self weight of the steel deck itself, 3 PSF is a reasonable approximation. And then if we had if we're dealing with lateral force resisting systems, we could go into the diaphragm as well. But right now, I'm just going to leave this in here, and I'm going to click add. And that gets us a deck that's that is a composite floor system with a 1.5 inch deck, 3.5 inches of concrete, 5-inch total thickness. Okay, and while we're here, I'm going to go to a non-composite floor system. You may be thinking, like, why are we doing non-composite? Well, really, this is for the roof. So I'm going to say like a 1.5 B or F, or let's just say 1.5 roof deck. Okay, because what we're going to do here is we're going to say this is also going to be, let's say, 2.5 pounds per square foot. You could say 3. And then here for diaphragms, you can give diaphragms as well if you're using this more so for your lateral force transmission. But for this, all what we're doing is this is just a way to transfer loads from the floor or the roof to the beams using tributary areas. So that's what we're going to start with. It's just this, right? And it also gives a self weight if you're using that self weight. So I'm going to click OK. But now I still have to go define where those are, right? So under slab, I still have to assign that deck. And this is critical here, right? When you assign the deck, you have to make sure that your orientation is correct. So with the deck, you can see our joist span left to right. I'm going to use my deck orientation of up to down, right? So when I assign this, I'm going to do a composite deck on the floor, 1.5 VL, and I'm going to add this to the whole floor. And you can see now that these magenta lines, they're spanning from one joist to the next. They're one-way, one-way slab span, and it tells you what was assigned to the floor. You can also see where the openings are that we left in there, and this really gets us where we want to be. Okay, before we leave here, one of the things that I also want to do is I just want to keep going down here for a second, and I want to put some loads on. Okay, so under, we did slab, now we're going to loads, and you see again, there's no loads that show up here. We have to go and define those. So I can put a surface load in here, and I'm going to say this is just going to be my, let's call it a floor load. I'm going to use 85 pounds per square foot for my dead load. That includes the deck weight. It includes the concrete weight. It includes any light fixtures and all that sort of thing. The construction dead load, you could reduce this from 85. This is kind of what you're going to use before you're into composite action. For what we're doing, we're not so worried about that. We could reduce it conservatively. We could leave it 85. I mean, it's not going to be any more than that. The live load that I'm going to use for this floor is going to be 80 pounds per square foot. I'm going to make this unreducible to start, just because, again, when I'm checking this model, I want to make sure that it works right, and I'm going to start with unreducible. I'm not going to include a partition load here. I'm including that kind of within the live load. You can change it if you want. A construction live load, this is kind of the construction workers, especially during a non-composite event. I'm just going to put in 20. And the mass dead load, this is where, again, it gets towards seismic design. I'm going to leave an 85 for now. But if you get into lateral and seismic design, you can take a look at that more closely. So after I click add, I still need to go and assign that to the floor. So after I click add, now I have a surface load that pops up here. I still need to take this floor load and assign it to the whole floor. If you had different floor loads on different parts, you could put those in different areas, but for what we're doing, I'm just going to take that and put it to the whole floor. And then the other thing that I'm going to do is I'm going to come back here and I'm going to go and define a line load, because around these stairwells we're going to maybe put a masonry load. I'm going to say 0.8 kips per foot. Really, these aren't there in the non-composite condition. I could leave this blank. I could put it in as 0.8. There is no live load. This is all dead load because it's just masonry. There's no partition. There's really no construction live load on this as well. I could leave this in at the mass dead load as well, which will be fine. So I click add there, and then again, what I need to do is I need to go in and lay these out. So I'm going to take this load, I'm going to make my live load, and I need to assign this line load to certain places. I'm just going to click add here, and then what I'm going to do is I'm going to click. So click once, click a second time, and that assigns the masonry load to that spot. I'm going to click once, click a second time, click once, click a second time, and basically just find my way all around this stairwell. And you could say, well, what about an opening? Yeah, we could get there and refine that a little bit more closely. But for what we're doing in this video, this should be fine. So if you need to, come up with a point somewhere in between, you can also, reduce your masonry load where you need to. But for what we're doing, this should work well, because what that does, it gives us our masonry loads. You may be saying like, wait, where'd it go? When you click off, it goes away. And not that it's gone, but it's just you can't see it, right? So if I click on my line load, if I ever want to see something like this, I can come back here and I can click show. And this will show me where those loads are. Okay. So that's kind of where we are with the loads. And the floor is pretty good. All right, the floor is pretty well set up. But the next thing that we have to do is we have to go back to the roof. And honestly, a lot of this stuff is going to copy to the roof. So what I'm going to do is I'm actually going to go to layout, type, select. I'm going to select my floor, and then actually what I'm going to do here is I'm going to go and I'm going to change because what I need to do is I need to create a new floor. I need to essentially create the roof. Okay, so I'm going to add this in and add the roof in. Okay, so now I have a roof, and I'm going to select that roof, but it's blank. And what I want to do is I want to take the majority of that floor and copy it over. So I'm going to take this floor, I'm going to copy the grids, the beams, the joists, the columns. There are no walls. I'm going to leave the decking off, and I'm going to leave the loads off because those are going to change. Okay, so I'm going to bring this over, and you can see a lot of the same stuff is there. But what I want to do here is I want to come and I need to delete a few things. So for example, I'm going to delete some of these joists. So I'm going to fence delete some of these. I'm going to take these joists away. I'm going to take these joists away. Where did we go? So these joists, and then I need to do the same thing with the beams. So I'm going to change to the steel module, and now I'm going to come back to beams, and I'm going to delete some of these beams. For this, I'm just going to use single and just click on the beams that I want to delete. Okay, and if you'll remember, there was a HVAC unit on this roof, so I'm going to add something off a grid. I'm just going to say let's offset this like 6 feet. You have to go and actually look up what the curb is, right? Like what size this curb is. But let's say it's six feet, and then let's say in the other direction maybe it's 14 feet. I don't know. You'll have to go look that up. But now we have this opening kind of we have the unit framed out for the HVAC unit, or the steel framed out for the HVAC unit. Okay, and then I need to change back to my joists, and I'm going to lay these out again. So now I'm going to add generation, and within here, what I'm going to do is I'm still going to do 5 equal spaces. So I'm going to start here, come up, and select where I want those joists. So same type of thing that we did before, and what I'm going to do now is I'm just going to add these in. And now this one, you can see it's kind of a unique spacing. So what I'm going to do here is I'm just going to right click, and I'm going to say, rather than generation, I'm going to come into joist, and I'm going to assign off grid, and I'm going to pick let's say 4.5 feet. And you can come up with something specific if you want, but that's going to be close enough for what we're doing here. Okay, so that's pretty good. What I need to do next is after I get my joists and beams set up, I need to do my slab again. So first I'm going to do my slab edge. 8 inches is good. That's going to be the whole perimeter. Okay, right click, cancel. And then what I need to do also is I can't forget those slab openings. So I'll have my slab opening. I'm going to add a slab opening in the bay. So I'm just going to click in the bay that I want my opening. And you can, change your slab overhang if you need to. But, whatever it's going to be, you need to do it correctly. So there's my slab. My openings are good. And then within the slab, I need to assign the deck. So here, again, what I want to do is I want to pick the right deck. So here we have our non-composite deck. I want to make sure it's spanning the correct direction. And then I'm going to apply it to the whole floor. I had some students once that were working on a model, and they kept wondering why their loads weren't coming out right. Well, they had the deck spanning the wrong direction. So instead of the tributary area kind of being distributed correctly, it was taking all the load back to the beams, and these joists had like nothing on them. So just something to consider. You can tell which way the deck spans by the way in which these magenta lines go. Okay, and then I still need to come back here. I don't think I ever defined my roof loads. So I'm going to call this my roof load, and I'm going to say maybe we have 35 pounds per square foot dead load. Construction dead load I'm not going to get into, but basically, again, we have a non-composite situation, so this really isn't going to be impacted. There isn't really, well, we could put a 20 pound per square foot roof live load, but again, since we already selected snow, it's not super critical unless we go back and change that to check what's going on with the roof. There's no partition load. Construction live load, I'm going to put in 20 pounds per square foot. Mass dead load, I'm going to leave 35 as well. Okay, but again, if you get into seismic design, you have to take a closer look at that. So I add this into my properties, but I still need to add it to the floor. So now I can come back, I can apply my surface load, I can pick my roof live load and apply that to the whole floor. Okay, even though the floor is a roof, it's okay. And then what I have to do here is I have to come back, go to my line load, and I'm going to apply a line load for the HVAC unit. So I'm going to say that's maybe a 0.5 kips per foot, and just kind of go with that. Okay, so I add that line load, but now I need to actually apply it to the model. So I'm going to pick this, and maybe you're using point loads. You can put point loads in. Okay, but I'm going to add that to the model here. And that should be good. Now, some of you might actually leave this diaphragm not with an opening, so you get your snow load on there too, and that's perfectly fine. Also, it's probably honestly a little bit better. So the last load that we have to add here is going to be our snow load. And if I come in here and pick a snow load, now I need to call this snow. And just because we added a roof dead load and even like a roof live load, that doesn't matter, because what we selected early on in the properties was that we're going to use snow instead of roof live load. So we have to add that. I'm going to use a 45 pound per square foot snow load, which is a reasonable number, but you have to go get that through your code analysis. And then again, what I have to do is I need to go here, I need to apply that snow load into the entire floor. And again, if you wanted your snow load on this opening, just leave an opening, or leave this not having an opening here, but you could also include that snow load in your HVAC line loads as well, depending on how you want to do that. So there's our snow loads as well. So we went through and we had to get all those loads, including the surface line and the snow load. And then we've gone through these various pieces. The last thing we kind of need to do here is to set our story heights. So what this does is it allows us to, if we wanted to do a 3-story building, we could apply this floor type to multiple stories. For our building, we're just going to use a 2-story building, so I'm just going to put one floor in here. I'm going to say my floor to floor height maybe is 16 feet, and you can adjust this based on where your deck is and all that sort of thing. But basically I need to add that in, and that's the first story. So the first story height is at 16. I have this splice level set to no. That's kind of the default that I use here. It might be set to yes. What this means is whether or not that column is going to be spliced at that level, right? And it makes a difference with your analysis. But also in a 2-story building, typically we're not going to splice the columns. We're just going to get columns that are maybe 30 feet long, bring them in, set them, and set everything that needs to be done. So here, for example, I can put a roof in. I can say my floor to floor height for maybe the roof is going to be, 14 feet. So a little bit less. Sometimes that is the way the architect sets it. So I can add that in. Now I have my roof, my floor, and I can click OK. And basically what happens now is if I click my 3D view, we see that all of a sudden now we have stories, right? So we have this, first story or second story, depending on how you want to look at it, and we have the roof. You can see the openings for the HVAC and the stairs here. If you hold control, you can kind of pan this around here, which is kind of fun because you get to see, you have your beams, your girders, your joists, the different framing for the openings. And it's just a nice model. I mean, honestly, we did a lot of work right there to get to this point, and the program's going to do an amazing amount of work here to design all those beams in a minute. So again, if you wanted to add other things like foundations, you could add foundations, you could add frames for lateral analysis. This video is not going to get there, but those are other options that you can do if you're taking this further. But for the first, intro to this, I don't want to get too crazy. So there we have it. So once you have that, I mean, you can save this thing. You can close the modeler, and what happens here is you have some red dots show up, and this means that we've created some beams, we've created some columns, we've even created some concrete in that deck, and we can do an analysis now of those. So what I'm going to do here is we have our criteria model design, and that's where even under design you can see we have our beam, our column, our frame. I'm just going to come here and I'm going to click on the beam design. So with this, what we have is it says, we can click perform design all, which is fine if we want to, or we can just do this manually. But basically what you want to do is you want to come in and look at your criteria. So steel design code, you know which code you're using. We're using AISC LRFD. Okay, maybe you're in a design office that uses ASD, you can switch that there. Demand capacity limits, so typically we're going to use a unity ratio or unity value of 1, right? This is our demand, like our ultimate moment over our FMN, our capacity. Okay, and then design defaults. You can change the span to depth ratio, and this kind of gets to the point where it sort of sizes the height or the depth of those beams. I like to have this checked on, this CB equal to 1, especially when I'm first starting. I can go back in the model and tweak it after, but when I'm first starting, it's a lot easier to do hand calculations to check the model when I can use a CB, a lateral torsional buckling coefficient here, of 1. It just makes using the tables in the manual a lot easier. It makes using, coming up with the moment values for design, I should say the lateral torsional buckling FMN values, the capacity values of that beam a little bit easier when we first start. If you want to, after you verify your model, you can come back here and check this off and rerun the analysis. Typically, I like to say the deck perpendicular to the beam braces the flanges, and when I'm using joist, I say the deck parallel to the beam does not brace flanges. So I leave this check mark off because when you think about these joists, right, these joists sit up 2.5, 5 inches or whatever above this girder. So the deck doesn't actually sit on this girder. The deck sits on the joist, brace the joist, but these joists provide lateral bracing for the girder. So I like to leave that one off. If you have a full beam system, you can leave this up here, but that's where the perpendicular braces a flange versus parallel braces the flange. Okay, you can do more composite information, but right now we're just starting with non-composite design. In addition, as we look at this, we can look at camber. I like to come for non-composite. Again, that's what we're doing. I like to just check this do not camber box on. It might not be checked when you first start here, but some of the defaults that I have set here, I like to check do not camber. Again, when I'm first checking my model, I like to be able to check it and check to make sure that everything matches up. And then after I'm done, right, after I'm done with those checks, I can come back and say, okay, now I'm going to camber it, and I can say how much I want to allow it to camber. Okay, but first I'm just going to leave it with no camber. Studs, again, if we're doing composite design, we could look at that. If we had web openings, we could look at that. Joists, we could take a look here, but the joist criteria, what we have is these are just standard Steel Joist Institute joists that we're going to use. One thing to note is that you have to include this joist weight, especially as we're thinking about dead weight and dead load and that sort of thing, self weight. We checked the boxes off. So our dead loads include an allowance for self-weight of the structure. And that's really important because even if you leave those boxes checked, you still have to include an allowance for the self-weight of your joist. So just something to think about. But this, these are the tables that you can use for your joists. Okay, so we're going to leave those just as they are. And then, if we come in for type, we can look at the roof or we can look at the floor. We can change that with this drop down as well. We can assign sizes if we want to. We can assign deflection criteria to certain beams. I'm going to leave that off and let the program do it, because now when I come to process, this is pretty cool, because what I can do is I can just click design all, and all of a sudden you see that little thing, that little progress bar going. That did a lot of work right there, right? Because now we can view, update, we can view a particular joist, and we can see that this is a 20K4, which is what was picked, which is pretty cool. I mean, we can change our joist size here. You can see the demand to capacity ratios for strength and deflection. We can optimize this. It should be optimized already. You can view results. You can view loads. You can do all sorts of things here, and this is pretty cool because even with this, right, here's our standard joist selection. It tells me what the joist was picked, what the length is, what the loads are, and the different criteria that we're going to look at for our joist design. We can come in and take a look at diagrams here as well. But basically, the joist that joist gives us a lot there. That joist report, or the analysis, whatever, gives us a lot of information here. We can do the same thing for a beam, and this shows us what the beam is. Right? It shows ZX, which is a major factor, especially when yield is the primary or controlling flexural strength. We can again look at our results here, and these results give us what the point, if there are any point loads. That gives us our line loads, and as we come down, we can see as well what we have for reactions. So we can go and check those manually, right, to make sure that the loads we think are on that beam are actually on that beam. Is super important and super necessary step in all this. Okay, so you have that going on, and I mean, we can take a look at our diagrams here as well. And this is kind of cool. When we take a look at this diagram, let me pull it over onto the screen here. And if this is up here, what you can see is a shear moment diagram, right? And this is cool because you can see the dead load, maximum moment, negative moment. You can take a look at your load combinations, and this should give us, our total load here that we have to, or we're able to design for. So a pretty cool thing, pretty cool, like in terms of what this allows us to take a look at as well. So what you can see here is there is a step, and that step comes from where we picked this beam. That step comes from this member framing into it with the opening. So definitely something that's pretty cool, pretty useful. Okay, so you can definitely look at that. In addition, what you can do is if you wanted to see some things, you can come to this View tab, or you can come to this Reports tab. I mean, for the reports, you can pick a report here. You can map the floor if you wanted to show the beam designs. You could print this, and what this does is it doesn't actually print it, but it brings up a screenshot that shows all these components, so you can bring it to whoever's reviewing your drawings. In addition, you can see that information where we could show reactions, or we could show beam numbers, or we could show our designs. In here, this is kind of a similar layout that shows each joist, each beam, which you could translate into a framing plan. So very cool, very powerful. We can come down to the floor. We also have the floor design going on here. So very, very, very cool, very, very powerful program. So what I can do now is I can close that, and you'll see this red dot turns to green. We can just keep working our way down. So I'm going to come to the column side here, and under the columns, what I'm going to do is you can see right off the bat that they're yellow. So that means that they're not designed yet. Again, we could look at our criteria. Still, design code hasn't changed. Demand capacity limit still 1. That's good. Our design defaults, you can take a look at this, but I'm going to leave that as is. So this has to do with calculating unbalanced moments. We're going to leave that as is. The trial groups, this is where I like to specify, and this is something I changed from the default, right? I like to specify, especially for like a 2-story building, I'm going to pick like a W8 section maybe, right? I'm not going to use like 10s, 12s and 14s for a 2-story building. I'm probably going to end up with an 8-inch column here. That's going to be plenty strong enough for what we need. So I can change these design defaults, and I would recommend that you do that as well if you're doing a smaller building like this. So once that's set, I can click OK. And then there are other options that you can do with bracing if you have lateral bracing in, or base plates if you're going to be looking at base plates and foundations and that sort of thing. So once that's done, you can assign bracing, you assign trial groups. If you have certain columns, you want certain sizes, you can assign the trial groups to certain sizes. But what we're going to do is we're just going to go ahead and design all. And what you see again is as this goes through, it populates the columns, and you can see that these different columns get designed for different values here. All right, so unity values, red is greater than 1, means what maybe your design group, it couldn't find anything that worked here. But what you can see is they're mostly in this blue or green or yellow. The yellow here is 0.9 to 0.95 unity, which makes some sense here. That's trying to optimize the design. I can go to view update, right? So I can go to view update, whether it's here or the button, and I can click on one of these columns, and this will tell me more information as well about that column, about the interaction equation that controls. And so we have our axial loads, we have our moments here, or moment unity ratios, I should say. Those moments come from the eccentricities of the loading, okay, and of the beam column connections. Okay, so that gets us a lot of information there. We can come to reports. We can look at a column report here, and just like we had on the beams, where we have a lot of really good information here. We have a lot of really good information, whether it's the effective length factor, it's the column eccentricities, our axial demand, right? Our moments that are on this thing, caused by these eccentricities of the beam shear. And then we also have some parameters down here. So if you're trying to check this manually, you can see, well, what is this using for like the second order amplification factor, for example, or what's this using for CB, that lateral torsional buckling coefficient. You might be saying, didn't you check the box for 1? Yes, we checked it as 1 for beams. For columns, it's a little bit different here, apparently. So that's something to take a look at, but this is one way you can go ahead and verify where your beam design is, and here's our unity of 0.9. Okay, so a lot of really good information there, a lot of really good information that you can get out of this program, and a lot of amazing design that this system will do for you. So that's kind of the basics of getting started with this program, and honestly, it gets you really far with that gravity design. And when you get into lateral design, you can add your bracing, you can add your seismic loads, and all that sort of thing. To do that, you're going to be jumping into ram frame, for example, and you can get into that as well. But for this intro, really, this is just kind of the nuts and bolts: how to get the model in, how to get a grid in, how to do your basic beam design, your basic column design, and how to get started. So I hope this video helps you. If you like it, let me know. If there's other things you want to see, drop a comment below. So if I can do anything to help, let me know. But otherwise, keep working hard and keep moving onward and upward.